everyone. Welcome back. Can we start coming back into the room, please, and sitting down so we can start? Perfect. So we're going to have a 45 minutes discussion where each group will have about 5 minutes to present what they discuss during the breakout group. And we're going to be both the online and the in-person people. The online people will be able to report. People, and then with the in-person. Yes, they have lost sound. Is it fine? Okay. Okay. Clotilde, if you're ready to give us a report of your breakout session, maybe you can start and we'll let you know if we can hear you or not.
Hello, can you hear me?
Okay, we cannot hear you yet, Chloe.
Can you hear me now?
Give us a moment. Keep speaking, but...
Okay, so in the breakout session, we were 3, and Barry, which is also online, and just switch on a... Oh, I can see myself. Can you hear me? Yes? Oh, I can see thumbs up. Good. So we were in the first session talking about ocean and climate downscaling, and Barry is going to report back. Barry, over to you.
Okay, thank you very much. Can you hear me? Yes, okay, thank you so much. I also saw the song. Hello everyone, I'm Bahare from the University of Strathclyde. So this is a very brief report of what we discussed in session 1. Starting from the first question about the selection of CMIP models and future emissions, pathways, scenarios for forcing projections with regional climate models. We discussed about the application of, using these kind of models. Selection criteria largely depends on the application and the modeling system. If you are going to use that for example, wave modeling or ESM, air system modeling. Also, it depends on the spatial and temporal resolution that we need for our simulations. And about the emission pathways, basically then we have to consider the non-linearity. So sometimes you have to explore all the options or all the future projections. Probably we need also to consider different time spans when we are talking about the future. It's usually like 10 yearly, but sometimes we have to expand that. And access to ensemble is also very important for different cases to reduce the uncertainty. About the second question, simulation strategy, transient versus time slice, spin-off and vice correction. So time slices, again, depend on the application. For example, if you're going to use that for wave energy, probably 30 years is enough. Sometimes not. We have to consider longer time spans to consider the decadal changes as well. And also, if you're going to use them for extreme value analysis, we have to expand that as much as possible. We also need high resolution ESMs, again, which are very expensive and require snapshots in time scales. Also, sometimes, and in several cases, we consider 2030 as the future horizon or the near future for climate projections, which is just 5 years ahead of us. So we have to consider that as well. And in terms of bias correction, it's very important for wave modeling to also correct the inputs to the wave model, which is wind. So bias correct the historical period and then future period the same way, assuming that for example, if you're using a reanalysis to bias correct the climate projections, you have to assume that the same relationship between the reanalysis and climate projections will remain in the future as well. And then we also discussed about the bias correction requirements for the incoming ocean currents. And about the third question, options for atmospheric downscaling, coupled ocean atmospheric or use of the regional atmospheric projections, for example, Cordex model. For the wave model, we usually use what is available. Again, depends on the scale. For example, we can use atmospheric oceanic models. So it varies between global, regional, or local scale models. When we have high resolution models available, of course, we can use that for the regions that we are applying that model to. For example, we can use Cordex, for example, for European waters. There are some older models, CMIP5 models, which are still available on high resolution, for example, MRI AGCM 3.2S, and higher resolution CMIP6 models, such as CMCC and FGOLS, which Chloe mentioned she's using. And also Cordex, of course, as I mentioned. And regarding the fourth question, global ocean downscaling, force global ocean models with high resolution and or better processes representations, we discussed the possibility of using AI or machine learning for climate downscaling. One example in this regard also was the ECRs model that we used recently for wave modeling. We used a single model, single scenario with multiple wave models just to see the differences between the wave models in projecting the future waves. And also discuss the possibility of using unstructured model as a solution when it comes to wave modeling. And also, okay, we also had a discussion about the accessibility of these technologies, data, etc., in locations that we don't have much access to. For example, in Africa, we might have we had a discussion about the coastal areas of Africa, and then if we need to transfer this kind of technology or knowledge in the location where we are in short of data and climate projections on a regional scale. And that's it from me.
Should continue with the online group, maybe theme 2, if they are ready to give the report. Hello, can you hear me? Is Andrea there? Because he's going to be in a meeting.
Hi, can you hear me?
Yeah, Andrea, we can hear you.
Hi, wait, sorry. Hi, everyone. So yeah, we gathered for theme 2. We were about 5 people with different backgrounds and different areas of what we were doing. And actually, I don't know if I can share. Maybe we can share the notes.
Okay. Yes, you can share. Yes, Andrea, give us 1 second. Yes, you can go ahead and share.
Okay, can you see me? Can you see my screen?
Yes, yes, we can see it.
Okay, so we basically try to tackle a little bit on each one of the topics. So for the first one, we just went around whoever was online trying to talk into the different areas in which we were working. So we had working from waves to physics in the Arctic. We also had a study on unstructured grid in the Northern European Shelf, some coastal studies in West Africa, on the Italian coastline. So we went around gathering what it is that we do right now and what would be our ideal setup for forcings. And we came up with, well, at least for all of these case studies, and we came to a, let's say, agreement that ideally we would have different frequencies, temporal frequencies, ranging from 3-hour resolution to daily information up to monthly information. And then the resolution, which is where most of us struggle because we have to do different nesting models. Then we have from 10 kilometers up to 1 kilometer. So for example, the person that was studying surges in the Italian coastline, he was directly using information on surges from gauges. So that way he needed information on a very high resolution in order to have information throughout the coastline. So that's the 1 kilometer. Then the rest of us were working with local models that was usually getting information from a regional model. Then we talked a little bit about bias correction, and there we were just discussing, I would say, like, some people agreed that we need it. Some people said, okay, we can maybe go without, but we all said that we need a definite protocol on how to do it. And of course, there are benefits and drawbacks, and we try to enumerate a little bit of those that could allow us to then set a protocol into what it is we need and for which cases. So for example, it depends on the number of outputs you have, then maybe you can do it in a certain output of your local model. Or if you have a limited number of forcings, then maybe you can do it in the forcing and then have your coastal model already using bias corrected information as forcing. And finally, we had a very quick talk on coupling. So we think that for some applications, coupling is not necessarily crucial, and we can go with doing nested information, and it would allow us to do for certain applications. But we have a person from Brazil, and she was talking about how in the northern part of Brazil, there is a very important long wave formation that basically dominates the whole dynamics. So for that case, coupling is very important for a regional climate model leading up to the coast to study surges. So we just came to the conclusion that maybe coupling could be defined depending on the region and its actual dynamics. And that's about it. We didn't manage to tackle the 4 questions.
Thank you very much, Adria. That sounds great. Thank you very much for sharing your screen too. Okay, can we move to theme 3 then? Sarah? Sarah, can you hear us? You can present when you're ready. Please, Andrea, if you stop sharing, that would be great.
Okay, thanks, Anna. Yeah, so we were talking about biogeochemistry and ecosystem modeling. So the first question on simulation strategy, spin up and biases. Someone mentioned the use of AI and use drones for Okay, can you hear me? Sorry.
Yes, we lost a little bit the connection. So if you stop, we mentioned, you started speaking about bias correction, but we didn't hear anything about that.
Yeah. Yes, okay. Okay, I'm getting a bit of feedback actually.
Can you hear me fine?
Yes, I can hear you. If you can hear me, I can bear with it.
Yeah, we can hear you.
Okay. Yeah, so one of the topics of conversation was around access between regional and international data sets and the importance of being able to share ideas and data, how to use modern AI methods, and bias correction methods. Particularly important, the idea of a protocol, but we didn't actually come up with any sort of protocol, apart from the sort of, it's a comparison between observations, and one method that was mentioned was quantile mapping. And the next question was about forcing data, including missing data. And again, we broadly supported the need for a protocol in these cases for uses of CMIP model and reanalysis data, which is also being used in these studies, particularly around data that might be owned by national agencies. Another important data source are remote sensing products, and one of the challenges was around missing data and how you complete your data sets if you've got time periods or regions missing. One of the methodologies being linear interpolation through gaps, but also statistical downscaling, particularly if your data available is monthly or weekly and you want higher resolution, higher frequency processes, how you can statistically recreate data at higher frequency than is actually available. More information about the importance of comparing with observations. And we also had a list of various data sources. It's all on the Google document around satellite and the different NOAA and Copernicus products that are available. One topic we talked about very briefly was riverine inputs. We didn't have a lot to say about that apart from the possibility of using empirical relationships and more machine learning to sort of fill in, particularly in climatological data sets, to sort of fill in climate projections of riverine data. One of our other question was around the pelagic benthic interface, and the main thing here was around the spin up, because benthic models, sediment and pore water processes operate on long time scales and need a long spin up. And I guess this depends very much on your region, but you know, the spin up can be of the order of years, but it's very important, and that probably precludes using time slice experiments unless you can sort of spin those up adequately. One extra thing we did spend a while talking about that wasn't one of our questions was protocols for good practice in sharing of information and data. And we talked about methodologies for improving model accuracy, reproducibility, and generally collaboration around making your things open source and traceable, maybe using GitHub, including examples and test cases so that you can people can reproduce what you've done and then know that the methodology is the same. Also, Jupyter notebooks were noticed for that. And also the importance of using standardized data protocols such as NetCDF or CSV formats. And using open access repositories such as Zenodo and Pangea. One thing we thought was that funding of cross-national, international projects would be also good practice in sharing methodologies for doing things. And we had several participants who came from sort of East African regions and had various points to make about data in Yemen and sort of the Red Sea, Arabian Sea area, and keen to sort of share data in those regions, but again, it was difficult to work out how that might be possible. Okay, I think that was everything. Thank you.
Sarah, that's great. Can we move to theme 4? Lucy, yes. Lucy, if you can hear us, please go ahead.
Can you hear me there?
Yes.
Great. Hello, everyone. So our session was all about user perspective and how we can deliver and make the best use of our data. So our first question was about outputs and metadata we came out with sort of 3 points from this, which is firstly what to publish, how to find it, and how to make that data more accessible. So we talked about different levels of complexity, from the sort of full heavyweight data sets to lower level, more user-friendly data sets. Maybe being able to interrogate these things with like a GUI. Depends on what the user wants. Some want short 1 month case study events, some want long statistical decadal stuff. So we kind of can't second guess what users want. So we just need to make sure it's all accessible. We talked about using data hubs, very accessible, searchable, and maybe making use of machine learning to interrogate the data sets, because it's not necessarily easy to find what you want. There's been some work with chatbots to help you interact with sort of providing a verbal summary of the data or just working out how to find it. So again, making uses of large language models to interrogate the data set and find what you're looking for. We talked a lot actually about metadata, the importance of quality flags, data quality, but also to explain the uncertainty where things have come from becomes particularly important when you're doing climate forecasting, but also just kind of a health warning on the data, what you can use this for, what it's suitable for, what maybe it might not be good for. Then we moved on to the target regions for case studies. We didn't necessarily think that it was good to try and direct this or pigeonhole it. People are already working on their sort of local areas or chosen project areas. So maybe it's better to make more meta-analysis of what's already out there, because regional MIPS, often when you try them, you kind of end up not finding enough overlap. So better perhaps to make a global database of regional models. And then that's a good way to identify these hotspots where lots of data exist. You can make a meta-analysis, but also for gap identification, showing where we could improve and focus our efforts in the future. We talked rather than specific areas about archetypes. So this could be a particular physical system, sort of long exposed coast, remote islands, enclosed seas, estuarine systems. And is there sort of transferable information for sort of the way to set things up, good practice for building nesting, also post-processing for these different coastal archetypes that are kind of transferable between sites. And to do this, these community models have to be interchangeable, usable. So things like Sarah was saying, consistent data types, Jupyter notebooks. And again, explaining which of these tools is suitable for that particular area or that particular archetype and what isn't transferable. So all of these need to come with a health warning to explain what they're good for and what they're not. The third question was about model nesting and what's the best strategy for that. Again, it kind of comes back to this archetype. So if you've got a exposed Pacific island, which has got a lot of swell waves, it might not care so much about the regional winds than the incoming open boundary, but somewhere like a semi-enclosed sea like the Adriatic, you need those super good high resolution, high frequency winds to get that right. So knowing what the physics is helps design that case study and design that model nesting configuration correctly. We talked about trying to work a bit smarter with our downscaling, so making use of statistical downscaling, identifying synoptic patterns and systems. So rather than running decades of highly complex, high resolution coupled models, try and maybe use those longer time slices of coarse models to put the context to the downscaling that we want to look at to focus on particular event scale, and then trying to then upscale that back to the climatology and see where these archetypal or case study storms or systems fit into that larger climatology. The last point was about social drivers. So our question was, what's important to the users in those case study regions? And that comes back to this data being really fit for purpose. Who's going to use it? And does it really match that user need? To do that, we need to have better communication with our stakeholders to find out who's using it, who wants to use it. Often the nice thing about this sort of publishing data on completely open repositories is everyone can use it. It's democratic, but that means it has to be suitable for everyone, and any feedback to know who's using it. So this could be through traceability of DOIs, identifying those stakeholders, seeing who's using it, identifying those communities, and then having a dialogue to make it fit for purpose. What do they need? Have we got the right resolution? Have we got the right locations? Whatever. And if we want to have meta-analysis of comparison data, these need really good planning in advance, really need to be well coordinated, not tried to put together after. We talked about this monster models, these Frankenstein methodologies where people are tried to add things from slightly different periods or of scenarios, and then it's not really meaningful. And this is particularly important when you're coming to things like compound hazards, where you've got your your waves and your surge and your rainfalls, if they're all coming from slightly different realizations, then you're not going to get a consistent projection of that future risk. And the final sort of the take home for me was, what's the action? Well, that the method, the onus is on us to make our data available and accessible, but not only by technical users. So open access data is one thing, but it needs to be understandable, usable. So this can be so training, right? So CMIP literacy, telling people where to get the data, but how to use it. Here's some example scripts. This is how you do a plotting, everything hosted in the cloud. So you don't have to have a supercomputer to be able to download your NetCDF. You can just like get a quick look at it. And also sort of stakeholder training to know what, to give these health warnings to the data, know what they are suitable for, what they're not suitable for, and helping people to find them. And that would just massively increase the uptake of our data if we had this community spirit and training to get this great work out there. Okay.
Yeah, that was great. Thank all our online participants again. So let's move now to the in-person. Should we go opposite, start from theme 4 to continue from what Lucy was saying? Why not?
Okay. Okay. So so in theme 4 we had a very wide-ranging discussion. It didn't necessarily follow the questions laid down, but I think it was still pretty useful anyway. And I think actually Lucy has kind of articulated a lot of what we covered. So I think one of the biggest challenges is actually down to the stakeholders and end users, and the fact that there are very many of them. And then how do we build the connections to those? Am I? No? Okay. Is that okay? Is that better? Okay. So so the point there is to take advantage of the UN Decade activities going on. So we don't actually have to do all of this ourselves. And a lot of the activity is happening within Coast Predict and within it, other actions. And actually building on using intermediate users of this, so it doesn't necessarily have to be direct connections between the downscaling model practitioners and the end users, but going via intermediate users, actually including social scientists, particularly, who can provide layers of different information on the information that we can provide. We identified really the importance of building and using trusted connections, and that trust is well, quite a scarce resource at the moment, particularly with science, and that we need to find ways to develop and maintain that. And so this is, you know, trust between end users and scientists. That actually just having one stakeholder and using that stakeholder connection to provide an example, that may provide you know, prompt others to join. So we don't necessarily have to try to cover everyone in one go, but having one thread of connections. And I think actually Samantha's scallop example was a really good one to start with. Is actually, if you have, you know, kind of one end-to-end connection, then other people could say, actually, I want that too, and kind of build on it. I mean, given this great variety of stakeholders, there is a big challenge in the whole co-design paradigm. That ideal of actually designing what we do with the stakeholders, and so we just need to have some balance of pragmatism in there, and we can't actually spend all our time trying to do co-design and end up not doing anything. And actually, at some point, we are just going to have to go and do something. So then the second question we touched on was, how do we identify case study regions, and to some extent we already have a list of potentials on that through the Global Coast survey of pilots. So I think there are about 60 regions identified there. I may be wrong in that. About 60 regions that we're interested in climate change information. So doing a mapping of which of these actually has any capacity or has some capacity in terms of future climate projections, identifying what the gaps in those are and seeing what the potentials for filling those gaps are, noting the importance of both stakeholder and in-country participant or in-region participant practitioners to doing that. In other words, you know, whilst I could sit in Liverpool and run a model anywhere in the world, it is not actually a very, you know, very helpful activity. Is pretty empty and shallow one doing that without connections of people who actually live and work in those particular regions of the world. And actually aiming to cover a diverse range of regions, and you know, particularly not just focusing on the developed world in this, but actually going to all continents, all countries, all different archetypes of coastal ocean systems. It's important to cover. And then finally, how do you actually provide information to end users? And it's important to have a hierarchy of information. There are some end users who are very sophisticated and require detailed, you know, essentially raw model data output. Others who want that to be highly simplified. So if you know, particularly if you wanted to communicate to kind of high-level stakeholders or in the education system, require maybe high level of simplification and synthesis of the information. And then finally want to be able to layer in socioeconomic data into the social science data that we might provide so that you can really get views of vulnerability to climate change. So I think that's probably covered most of it. I'm sure I've missed an awful lot, but we can pick up on that later.
Yes, we're gonna collate all the comments probably in a little report. So Yuri, if you're ready. Oh, Sam, better.
From our notes.
Oh.
Sorry, wait, give us some.
Oh.
Can we mute everybody in the Zoom? Can we share slides?
It's in the same folder as the note.
Do we have access there to the notes? No, it's not the same folder with the presentations. Can we put the, okay, just 2 minutes. It's fine. That's fine. No, it's good that you have slides.
Do you want to do another group?
My computers. Alfonso, do you want to do yours first? Oh, no, we can. Yeah. You give the presentation, and then Sam is gonna, when we figure out the technical problems that we have.
Yeah. Hello. We were about 15 people trying to talk and get into a common ground, and I think the common ground will be what Jason said. Is like it depends what your end user needs. So we decided that yeah, we have consider different modeling needs and get into what we want. Is it coastal erosion? Is it coastal flooding, coastal hazards, ecological modeling? What is happening? So we cannot say a protocol specific for one. If not, we have to do kind of a network of different protocols for whatever use we want. And we invite people to think about that more than a single one. And defining what you want, if we want what kind of runs we want kind of long-term, short-term, medium-term, but what does that mean for everybody kind of? At the moment, we are saying probably about 3 years for short, over 5 to 10 years to medium, and over 10 years to large. So we just need to know what to do. Producing modeling nesting, we have problems with the computational burden, and especially in different institutes, different communities, they might not have access to the computers. So we share the dream of Nadia, and we will hope we get eventually a coast predict cloud with a big cluster. One of the things that we have is especially the intermediate runs, to have it somewhere to keep it, which is for everybody to access, so we can we don't have to repeat every kind of regional model to make our local model work. So have, again, in the Coast Predict cloud or something like that, make it available and make a kind of part of being of Coast Predict that we're going to share that data, which that should probably be put in the agreement before it's for the ones that we haven't signed it yet. So I think it's a good idea. What is space and time resolution? It's again multiple nesting, different times, different resolutions, depending what you want. We were talking about coastal flooding and urban coastal flooding. So for that, you want like meters, but you are just looking at the flooding sort of thing with the oceanographic. So we see different kind of sizes depending on what you want, like from 1 kilometer to meters, depending what's the problem. But again, it was pointed out we have to find a period where we stop. We don't want to start doing the millimeter kind of resolution, which is impossible. We started talking about, again, in the same kind of breath, it was the different model approach that we're going to have. Again, we have certain models for coastal modeling, flooding. We have probably 2D models to do search inundation, but you need things like 3D modeling if you're starting to look at ecosystem problems or proper circulation problems. So it's probably a mixed solution to everything, because you need one fitting into the other somehow. We have to do a probabilistic approach, a big probabilistic chain, but we don't need everything everywhere. So we have to be selective and think how we get things. We have to manage the ensembles, how to present the outcomes, and how to present the uncertainty is one of the important things that we all say. We have to share the uncertainties and tell our end users what that uncertainty means, because yeah, if not, they're not going to trust us, and that's part of the trust building that we have to do. And we kind of thought of 4 streams in which to divide those networks, and it's going to be coastal flooding. And you have the hydrological part of it, the biological part, the sedimentological, and the economic issues that we are going to kind of divide. And that's from that you decide, well, or we have to design which kind of the protocols that we should follow. But those are kind of a bit distinctive one to each other, although they share certain things. Everything has to be discussed with users, as I say, starting. And we have to start connecting more with other communities. As we saw in the morning, we have to talk to the hydrologists and see where our fresh water is coming from and how to get that properly into our models. We also have to look at the meteorologists and when we start doing smaller scale, higher scale resolution, start looking how higher scale. How should we use higher scale resolution meteorological models? And again, if we need the two-way coupling, which most of us don't use. The strategy about being transient and time scale, that depends what you want to do. Again, if you want to look at kind of coastal flooding, urban flooding, you probably want to look at extremes and how those extremes are going to change with climate. But if you want to look at general circulation or ecological problems, you might want to look at how having long runs to see how these processes are changing and where you have your flip points probably. The accuracy of the projections is important, and it's important not to look how your bias correction is going to be, because and how does it come from? Because using bias correction from the hydrologists in the river might not be the same that happens with in the bias correction that you have in an estuary and then in the coast. So have a thought of how things are coming through. The spin up it depends on the type of physics that you want to resolve. And we have to kind of find a way to optimize how to spin up things. So if you want so it's doable. We need the transient time scales to get the variability into the interannual variability are also kind of the variability within the annual cycle, and the seasonal cycle. How does that change? The event time scale we need for coupling, we may less than with other issues, but we have to find things like models or get some idea of how accurate is your storm resolution, your storm track resolution, how good it's that to the future. Explicit representation of processes. We talk a lot about online and offline coupling, and I think we kind of decided that a lot of it needs to be online coupling because it kind of transmits all the physics into the other part of it, but we're not that's quite what we ended up about it. Although we were talking about using offline coupling just to make it quicker, but we think it'll be better to keep it online. About artificial intelligence and machine learning, we have to think about it and how this could be useful, for example, for risk reduction, search and rescue, and things like that. It's been used now, and how can we improve that? And if we can translate that into other problems. But we were seeing, like in many other data-driven models, that this probably just accurate within the data you're used to train it on with a scheme that is very similar. So we have to be very careful with that. And we have to start thinking how to integrate these artificial intelligent schemes into our methods for all, probably within that range of different conditions. How does it train? How do we generalize for the entire coast and models? We have to probably think as more like hybrid approaches with machine learning help to calibrate issues, and also with the data. And again, the data, we think that the coast predict sharing idea and cloud will be something very helpful to have to share our local data for calibration. And I think that's all, unless anybody says I missed something.
But thank you very much. I have all the notes. I'm going to collate everything. Samantha?
Thank you. Thank you. Perfect. Okay, hi again. So I'm going to talk about our biogeochemistry and ecosystem modeling in-person theme 3 breakout, which Yuri was the discussion leader for, and I was the scribe and reporter. And in attendance, we had a pretty big group that was of different backgrounds in terms of experience. I did my best to try and capture, and hopefully anyone can correct it in the notes if it's wrong. But we had some students, some faculty, some practitioners that are different types of agencies, postdoc. So kind of a broad range. The approach was kind of, Yuri presented the categories that we were going to sort of talk through, and then he kind of suggested that we kind of introduce ourselves, as we had our first comment. And so what ended up happening was that we kind of shared our experiences with each, whichever one resonated with us first. This is what I have experience with. And then discussion ensued. And it turned out to mostly evolve into a focus on needs, and needs on the historical runs, because a lot of people hadn't started doing the forecasting yet. Yeah. So the categories that we focused on were like the simulation strategy, the transient versus the time slice, the spin up and the bias correction. We mostly talked about what people were doing in general and not on these particular categories, because it wasn't necessarily, didn't really translate to the experience in the room. And then the protocols for forcing data, including missing variables from CMIP. I'll get to this because we definitely talked about that. And then the riverine biogeochemistry input, we spent most of the time talking about the last two, the riverine biogeochemistry input and the benthic pelagic interface. So in terms of simulation strategy, the historical, it was definitely the focus. A lot of people had just physics first, kind of experience, but they were starting to dig into the biogeochemistry, or were observationalists in the room as well. And the time slice seemed to be more approachable, like as computationally as well. So that's like where, right, you do 2 different time periods and do the delta rather than a continuous in between the two. And but we pointed out that sort of like the example I gave with the long-lived species, and there's some other examples where that might be more appropriate, even though the approach is more computationally approachable to do the difference. In terms of the protocols for forcing data, including missing variables from CMIP, that latter part is the part that got our attention. There really was a lot of conversation around a need for forcing from the biogeochemistry as part of the output, the river forcing in particular from the CMIP website. And so whatever the global climate models are using, there was a desire to have that, even at the longer, even monthly, but daily or higher resolution is preferred. This is always a push we have with the global models, is trying to get higher resolution in time at the regional scale. We discussed options and getting that feedback back globally, that CMIP has every round or a publicly available, like request for diagnostic variables from the next round of CMIPs. And I think the CMIP 7 one just closed, correct me if I'm wrong. Yeah, but that's like available to us as a way of putting in a wish list together. It's something we should, and a timescale we should keep in mind as a community as we develop these needs. And then it's important to have, this higher resolution in time, right? All of the forcing really, not just the rivers. The riverine biogeochemistry, this part is hard to decide what to do in the future forcing situation. When we spent most of our time talking about this, that you can, there's various options that people choose to do. And that some of us learned about a new a UN action, which this is capturing the notes, but we should definitely get the links from people that made the comments, that there's Water Quality Alliance, and there's a multi-model ensemble that predicting water quality changes from land to sea, and it's now evolved into a MIP. And so that was like really useful to find out about from folks in the group. And like I said, we're going to try to get the links so that we can put it into the notes for us for the future. Like I said, we spent more time on this one than others, so it's more than one slide. So then we had questions about kind of what the resolution was needed to do this, the interface, this coastal terrestrial interface, that interface is missing from a lot of models and should be high priority in development, similar to other comments that have been made from other groups. And a lot of times we're limited on the data available at this interface as well, and that estuaries can be a particular complicated place. And that one approach was to use a box model for this interface, and that has been used physically, and that they're working on biogeochemical transformations within that to kind of scale that transformation that occurs within the estuary before it goes to offshore. And that mostly the global models are balancing global mass balance between the river and flows and the sediment output, but that in the regional models that isn't obviously the main. I mean, mass balance is, but not like the way that they are interested in it. So then the variables needed, we talked about that a lot of times river variables and forcing have nutrient focus, but silica as a forcing nutrient isn't necessarily available. So we had a long conversation about silica and how it can be important at a coastal scale, or maybe for the patchiness of blooms or nutrient for limitation for HABs generation. Local impacts from eutrophication, and then like if you were to think about kind of damming activities and hydropower, what the impacts that could be on the local biota. So questions that are not necessarily important for the CMIP models, but would be more on the coastal scale. And then there's the growing interest in silica delivery from rivers. And there were some products that were available currently that, again, someone referenced that we could try and get a link for. And then alkalinity came up as well from the land in terms of groundwater and river biogeochemistry, that in large part we rely on regressions using salinity, but that kind of is a guess for the end member on the land, and that, you know, it can be wrong, right? Then we moved on to the benthic-pelagic interface, and this feedback system is really important. It's, you know, that we need a physical biological coupling in this region. A lot of times metabolic rates are a proxy for the biological demands, and one that are very responsive to variables like temperature and oxygen. And that ecosystem can have like physical feedbacks on the, and one example there is the coral reef habitat, which is obviously also having effect but from the multiple stressors changing with climate. And that coastal models need to be higher resolution than elsewhere. And we also brought to attention the Ocean Carbon Biogeochemistry Group, which is run out of Hui in the States, has a benthic ecosystem carbon synthesis workshop that I can also put the link in the notes for, and group. And there were a few of us interested in kind of learning more about this group. And they're starting a SEDMIP, trying to kind of think about this interface. So variables that we would need, subsurface observations, temperature and oxygen at minimum, but nutrient data is really critical. Benthic primary production observations, including different chlorophyll bands if possible. Turbidity and suspended sediment, benthic food delivery. Also, that one is not clear how we would observe exactly, but something that we need to draw attention is a flux that we need because, yeah. And that was it. Did I miss anything from the votes that are in the, no, okay, thank you.
Thank you very much, Sam. I hope you will share this presentation with me so I can report. Okay, I will try to summarize theme one very, very fast. Some highlights, because we discussed a lot of things that they have already been mentioned. Our discussion was a little bit chaotic, so we're going back and forth between different questions. So in terms of how to choose CMIP models, first we'll have to see what it is offered by the CMIP models, because a lot of variables and parameters that we need, they're missing from them. And some of this, one issue that was raised is that some CMIP models are very unrealistic in different regions. Like, for example, in the Pacific Islands, the results from CMIP, they don't represent the reality at all. And so in different regions, we may actually have to consider different CMIPs. And also, they should be considered based on the application. Maybe we can have a decision matrix within FLAME as a tool for selection to help us gather information of what should be using and where as a guide. At the same time, though, in terms of, another problem is the selection of SSP scenario, not just the CMIP forcing, and different sectors and different end users may have preference for different scenarios and different needs. But in the end, in terms of projections of climate change in regional ocean scales, all of this may be relevant because sometimes using a forcing from one CMIP model may lead to, example, more severe warming in a very modest SSP scenario than using another CMIP model with the more catastrophic SSP scenario. So maybe we should start using storylines instead of specific forcing, or like putting something in terms, like for example, if we are to reach 2 degrees warming within 50 years or things like that. We also discuss that we have to disseminate uncertainty. That's for sure. No matter the forcing that we use or the SSP scenarios, we have to really define the uncertainty on the outputs that we will produce. Transit or time slices. For us, there was a consensus that we were all in agreement that we have to use continuous simulations, and transit is the way to go, unlike some other people mentioned. I think someone highlighted that the end users, they were very keen to actually get what is happening in a continuous case. They understood it better. For bias correction, we had a discussion where, for example, Georgia was mentioned for the Adriatic Sea. It was very tricky to bias correct consistently your whole forcing, the atmospheric forcing and the ocean boundary conditions. And if you don't do it in a consistent way, it may lead to a very unrealistic response from your model. But on the other hand, if you don't bias correct, you can get the whole salinity of your model wrong. You can introduce the salinity of 1 PSU lower. And this may be very important for the ecosystem. You end up having a background salinity that is so wrong that your whole ecosystem community is so wrong. So it doesn't matter how it's going to change in the future if you don't replicate how it is today. We discussed about force coastal models versus coupled systems. And this is related to how important was the two-way nonlinear feedback, especially between the atmosphere and the ocean. Coupled systems are very expensive, and maybe carefully designed forced experiments may be the answer here for our case. And probably using these forced systems will be more easy to understand the response. However, we know that, for example, CMIP is missing good representation of hurricanes and storms. So in a non-integrated downscaling system, we'll miss that part too. Resolution, we did not agree on a specific resolution, but we did agree that tuning the parameterization of your model based on the resolution that you have is very, very important, and we should learn from the atmospheric modeling from that. I'm not going to discuss what we said about riverine forcing, and I just want to highlight one thing that we keep coming back to is if these projections are going to include extremes, and if we're going to be able to use these projections for standing extreme events. And that was very important for flooding prediction and coastal engineering applications. So if models are not able to include these extremes, it will be difficult to explain why we should use these models, again, especially when it comes to flooding applications. And I think I'm going to stop here so we can move on to our next discussions. So now we're going to go back to the rooms, different rooms that you were before. I think we have your names there. We have updated to session 2. Again, you can choose to go to another session. Please, for the moderators, if possible, try to discuss slightly different things from what was discussed in the previous session. But again, just go with the flow, whatever the people want. So we will come. No, we'll have, at 4 o'clock, you will stop your discussion and we'll have a coffee break, and then we'll come back here after the coffee break.